Lesson 34, extracting specific information / revision. So the idea of today is I want to quickly talk to you guys about how you can go about extracting specific information from a matrix, which is something that we've already discussed, but I wanted to go into just a little bit more detail. And then I was going to wrap up with, a quick little demonstration of simultaneous equations. Today's question here is today's lesson fact here is one that you guys can actually play along with at home. So the first thing you want to do is if you want to play along, you can do this with me. Otherwise, I'll get someone to, because I've got we'll get someone to call out. We'll go with, can someone pick a number between 1 and 16 on this grid? Who wants to choose a number?
11.
11. Beautiful. Let's go 11. Now, that means that, so what we're going to do now is, sorry, Tyler, you're a bit slow, but Tyler, you can choose the second number. The second number needs to be in a different row and a different column. So you can choose any of those numbers. Tyler chooses 14. Why not? 14. That eliminates this row and this row. Can I get someone else to give me a new number? What's the other number that you guys would like? 8. Okay. So that eliminates this row and this row, which means our last number is 1. So our numbers are 1, 8, 11, and 14. Okay. Now, I want to show you guys what's the power of this. So if you take these numbers, right, 1, 8, 11, and 14, what you can do is you can take those and you can add these numbers together. So we're going to add 1 plus 8 plus 11 plus 14. Those were our numbers. 1 plus 8 makes 9. Plus 11 plus 14, which 9 plus 11 makes 20. 34. Okay, cool. Now, that's all right. Mean, I'm glad you got here. So that's 34. Great, cool, whatever. All right, let's try just one more thing. Can I get, Mean, you're late, so I want you to choose a number between 1 and 16 in chat or out loud.
16.
16, beautiful. Okay, let's go another number. Who can give me another number that from one has to be in a different row and a different column?
1.
1. All right, we've got 4 numbers left to choose. We got, what's the last number that we're going to grab? You guys want 10, 6,
11.
11. So we choose 11. That means we have to choose 6. So if we go 1 plus 6 plus 11 plus 16, surely this can't equal the same number because that would be weird. But if you do it, 18 plus 16, now that's going to be 34. Ladies and gents, the cool fact about this is it doesn't matter which column you choose, you will always get 34. Now, if you want to, you can just admit that, hey, cool, this is just some kind of, you can just look at this and be like, cool, whatever, this is just a fancy little trick. But you can actually then go into and explore the mathematics of it. The mathematics is essentially, from my understanding of the mathematics is that each of these is actually just the previous row plus some number. So if you do this for all of them, that means that essentially what you always end up with is 12 plus 1, 12 plus 2, 12 plus 3, 12 plus 4. You see, the thing that I like about these problems is some of you guys are going to take this away and firstly, the majority of you guys are not going to pay attention to this. Secondly, some of you guys are just going to take away, hey, cool, you can, it's always going to add to 34 as long as you choose a different number in a different row. But the nerdy ones of you that are like me will maybe be interested in why it actually works. So if you choose one from each of these columns, then you will always have 0 plus x plus 4 plus y plus 8 plus z plus, I've screwed up here, plus 12 times w, whatever. Okay. Now, it just so happens that the x, y, z, and the x has to be from this column, y, z, and w have to be 1, 2, 3, 4. So that means you're always going to have 0 plus 1 plus 4 plus 2 plus 8 plus 3 plus 12 plus 4. If you add all those together, you always get 34. Even if you swap the order of these x and y's and z's, you always get 34. I guess you could apply this to, this could be turned into a 4x4 matrix, and you could actually, and there actually are a lot of matrix methods you could apply to this that are a bit more advanced. Again, you don't need to know the why, I just thought I'd show you this. It's a bit of a cool little like Easter egg little thing, and it's like, I don't know, I think it's interesting. Today what we're going to do is we're going to, let's grab a look at extracting some information, and then I want to hit you with some revision stuff. This is just a quick thing that I put together. And what we've got is we've got nurses' hours. Now, we've already done this sort of stuff already. I guess this could be a bit of a revision. I just wanted to take it one step further for you guys. So what we've got is we've got 4 nurses working at a hospital. We've got Nurse Carla, Nurse Joy, Nurse Peter, and Nurse Samantha. And so these nurses are working. These nurses are working at this hospital. By the way, also another bit of an Easter egg, if you can tell me which franchise these nurses come from. One of them's easier, but yeah. But what we could do is, let's just say I want to know, let's just say that I want, let's do 2 things first. Let's find out how do we find the total hours worked by each nurse. How do we find the total hours worked by each nurse? Well, we could look at this graph and we say, well, we could look at this matrix and say, well, we need to add every single column. We need to add every single row. We need all of these rows added. Now, if you've written down in your notes, you should be able to know, okay, do you need to put a row matrix at the front or a column matrix at the end? But if you don't remember, it's like, well, okay, that means that every single thing in this row needs to be multiplied by a column, because it goes row, then column. So that means I need to make a column matrix. And what's, can you guys tell me, what am I going to put in this column matrix? Ones or zeros?
Ones.
Ones. Thank you, Cindy. And thank you to Lena, who also answered. And how big, oh, here's a harder question though. How big is this matrix going to have to be, the one on the right? How big, what's the dimensions of this matrix? Let's call
7
this,
by 1. Oh no, no. 4 by 1. Lena said it.
Is it a 4 by 1? If this is a 4 by 7, this is not going to be a 4 by 1. You guys are a little bit incorrect there. What do you guys think it's going to be? It has to be what?
4 by 1.
It's not a 4 by 1. It's what? this has to be multipliable. So this has to be a something by 1. This has to be a 7 by 1. 1, 2, 3, 4, 5, 6, 7. So if I call this matrix B, or well, let's call this matrix H for hours. Okay. Or actually, no, we better not call that matrix H. Let's call this matrix B. So therefore, if I take matrix A and I multiply by matrix B, I will get a matrix which has all of the hours in it. Why? Because if I go 8 times 1, that gives me 8. If I go 8 times 1, that gives me 8. So 8 plus 8. And you're going to add all those together. 8 plus 8 plus 0 plus 0. It's going to be 16 plus 16 is 32. 32 plus 8 is 40. So we're going to have 52 for the first value, and so on and so forth. So that's why. So some quick points again about reminding you guys here. We want to add up all the things in this row, then I need to use a column matrix of the same length as that row. Now, some interesting, and this will add up all of the hours for all of the, this will add up all the hours for the first one, which is Carla, all the, this will create a 4 by 7 matrix. So a 4 by 1 matrix, sorry, because it's going to have 4 by 1. So there's going to be all of the hours. You're going to have, you're going to have all the hours for Carla, all the hours for Joy, all the hours for Peter, and all the hours for Samantha. And then that's going to create your table. Now, so let's grab a look at, well, what would it do? I want to now look at this side. What happens? Now I want to show you guys how we can now modify these, right? Well, let's do a different one. What if I, instead of wanting to know how many hours I wanted to know each person, what if I wanted to know instead the total hours for each day? To do that, I need to want to sum up this. So that means this is going to be the column. So before it, I need a row. Here's the question. How big is this row matrix going to be? What are the dimensions of this row matrix going to be? Yes, this would be a 1 by 4. Now, 1 by 4 matrix would, and that's going to be made up of ones. So we're going to call this matrix C. We're going to call this matrix C 1, 1, 1, 1. So that's going to add up all of the nurses for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And it's going to add all of the values for Carla, all of the values for Joy, so on and so forth. That will create, CA will create a, in this case, it's a 1 by 4 times a 4 by 7. So this will create a 1 by 7 matrix. 1, 2, 3, 4, 5, 6, 7. Now, the only thing that I wanted to add to this that was going to be a bit different is I wanted to show you guys one more thing here, which is going to be this. I'm going to do this in green. I'm going to show you guys this. What if, like, let's just say that, like, we got all this data in, but it turns out that, what if we had we just wanted to get, what if we wanted to just get the amount of hours that, what if we just wanted to get maybe the amount of hours that, like, Carla worked, right? Or we just wanted to get the amount of, we just wanted to get the amount of hours that Carla worked during the week. Well, instead of multiplying by 1, 1, 1, 1, we can multiply by 1, 0, 0, 0. I want to show you why. Because what that would do if you multiplied by 1, 0, 0, 0, you would have 1 times Carla, which is 8, plus 0 times Joy, plus 0 times Peter, plus 0 times Samantha. Then the next one you'd have 8. So you would end up with you would still end up with a 1 by 7, but all of these would be Carla's hours. So you can actually choose, and then let's just say maybe you don't want Carla's hours. What if we wanted Peter's hours? If we wanted Peter's hours, we put the 1 here. And so this actually allows us to figure out what one column is. If you you could even take this one step further. And this is something that I think is kind of cool. You could actually do this. Let me show you this one step further kind of thing. What do I think about one step further? Well, you could take, let me just clear all this. Just to show you the extreme here. You could take, let's just say, I want to know how many hours Carla worked during the week. We could multiply A by this matrix, and that would generate, that's a 1 by 4, that's a 4 by 7. So that would generate a 1 by 7 matrix. Then we could multiply this matrix by this. 1, 2, 3, 4, 5, 6, 7. Now this matrix here is a 7 by 1. If I multiply all of these together, then I will get a 1 by 1 matrix. And that 1 by 1 matrix will have the hours Carla worked. So it's actually combining two ideas. It's actually combining the summing of all the columns and the summing of all the rows together. You could actually do this with a 1 by 1 by 1 matrix. And all you would do is find out all hours for the week. But if you replace this with a 1, 1, 0, 0, 0, then you find all the hours worked by Carla. It's just a neat little trick that you can do. So let's say, let's see what else we've got. I wanted to do 2 little things to end up with, to finish up with. Would you guys prefer me to do the linear, and then I'm going to let you guys do your own revision. Would you guys like me to do the solving the linear equation first, or would you guys prefer me to do the house building example, which is something probably a bit different? The house, linear and the house. We've got 1 for linear, 1 for house. Any more votes? Let's do the house first, because again, I've got 1 vote for each here. So we've got this building house company, right? This is the same idea as that we were talking about. A building company makes 2 types of houses: cottages, family houses, and mansions. Below is the schedule for the company in March. So in March, they built 2 cottages in Victoria, 6 family homes in Victoria, and no mansions. Whereas in New South Wales, they built 2 cottages, 4 family homes, and 1 mansion. So what matrix and in what order must you multiply C to find out the amount of houses built in each state? We've just done an example for this. So let's hear. I want to know how many of each house is built. I want to know how many houses are built in Victoria and how many houses are built in New South Wales. I want you guys to tell me whether what do I need to multiply by? Tell me now. What are we going to do? And we've got one answer here. multiply by a column matrix is the first suggestion. Have I got any other suggestions? Have I got any other suggestions? Column 3 by 1. Okay, so we would multiply by a column. We want to sum all of this row. And remember, if we want to sum all of this row, we need to go row, then column. How big is this column? Well, this is a 2 by 3, so this has to be a 3 by 1. That's what you would need to do. So that's your answer to question 1, the 1, 1, 1 matrix. Okay, so the next one is going to be so what matrix and in what order must you multiply C to get the amount of each type of pass? So what would you do? What would you need to multiply? And what would you do for 2? I want you guys to let me know what you think you would need to do for 2. There's a reason that I'm doing this, by the way. Let's see. We've got a 1 by 2 row matrix, and that would be correct. If I wanted to solve this, I would get a 1 by 2 row matrix. So, and it would be 1. Why? Because if I multiply that by this 1 multiplies by this 2, and this 1 multiplies by this 2. So I'll get an addition of all of these together. Now, if I multiply C by the built-in time matrix, this, I can actually find out some important information. Let's see how this works. So instead of multiplying by 1 by 1 by 1, if I multiply my matrix by a 3, 6, 18, which is the amount of months it takes to build each of these, then I can actually create a matrix. Firstly, what size is this new matrix going to be? That's going to be a good question. What size is this new matrix going to be? Can someone let me know? What size is this new matrix going to be? Or the solution matrix. Is it going to be a 2 by 1? It is going to be a 2 by 1. Yeah. This is going to be a 2 by 1 matrix because this is a 2 by 3 matrix. Oopsies. And this is a 3 by 1 matrix. So the final answer will be a 2 by 1 matrix, which is going to look like this.
Wait, so the matrix, so though how we tell if the matrix can be multiplied together is within the number. For outside, for example, it says 2 and 1, right? So that means the 2 would be the column and the 1 would be the row.
Yeah. So if I go a 2 by, so let me do this. If I go a 2 by 3 multiplied by 3 by 1, these two numbers are the same. So that means they're multipliable. Tick.
Yep.
Then the final answer will be a 2 by 1. I got that by taking this and this.
Okay, so that means 2 columns and 1 row.
2 rows and 1 column.
Oh, yeah.
So now if I do this multiplication, 2 times 3 is going to be 6. 6 times 6 is going to be 36. And 0 times 18 is going to be 0. And in the bottom, we've got, going in the same order, 2 times 3 is going to be 6. 4 times 6 is going to be 24. And 1 times 18 is going to be 18. Adding all those together will give us the final matrix, which I'm going to have to do over here because we went out of room. 6 plus 36 is going to be 42. And then 30 plus 18 is going to be 48. So that's the time, the months in Vic and the months in New South Wales. So that could be a useful thing if you need to know, if you were trying to build this and be like, okay, we need to send more workers to New South Wales because they're going to have more hours of work. And that might be why you do something like this. Are there any questions on how I've done these three questions here? Right. If not, we're going to wrap up looking at some matrices. Now, I'm not going to do this one because, oh, am I? Hold on. Actually, 2 times 4, 2 times 7, negative 4 times 2, 8, 15. Well, we could do this one. It's going to be weird, but we can do this one. Sure. I think I made a mistake in this writing this question, which should make it harder. Let me just, it should be okay to do. Let's see how we go. If it doesn't work, then we'll figure it out and we'll deal with it later. But I think we'll find out. First thing we need to do is we need to turn this into a matrix. So we're going to have A, we're going to say A is going to be equal to 1, negative 4, 2, and 7. The next thing I'm going to do is I'm going to have matrix X. I'm going to say matrix X is equal to X, Y. And then what we'll do is we'll finally say matrix B is going to equal the answer, the solution, which was 11, negative 8. Which means if I take matrix A and I multiply it by matrix X, I will get matrix B. Again, another way you can check this is a 2 by 2 matrix. This is a 2 by 1, and this is a 2 by 1. So these 2's will cancel, which will give you 2 by 1. So that's the first thing that we do. Then we do a little bit of magic. We say, hey, if I knew what the inverse of A was, and I multiplied it by A, and then I multiplied that by X, I could do the same thing to both sides. Cool. But if I knew this, the inverse of A times A, that's just going to give me the identity matrix. And I know that whenever I multiply by the identity matrix, it's going to leave that X exactly the same. So that means if I knew what the inverse was, I could multiply that by B and I could get a solution. So next step, find the inverse of A. To find the inverse of A, we need to find the determinant of A. Determinant of A is going to be this, oh, whoopsies. You need this number times this number minus this number times this number minus negative 4 times 2. That's going to give me 7 minus 8. So my final answer comes out to be 15. Now the inverse of A is going to be equal to 1 over the determinant, which is 1 over 15. And then what I do is I swap the 1 and the 7. They get swapped. And the other ones get their negatives swapped. So this one at the top changes from negative 4 to positive 4. And this one at the bottom left changes from positive 2 to negative 2. Now you might say to me, okay, sir, now I need to multiply this by 1 on 15. And normally I would say yes, but I'm going to wait here. Because this is ugly, and yes, I am using the word, because this is ugly, we're just going to leave it at the front. You can do that, that's okay. And you'll see why in a second. Because it's ugly, we're just going to leave it. So let me show you then. Yeah, we do hate fractions. So what we can do is we can say x equals, the inverse of a is 1 of 15 multiplied by 7, well, this is, I guess, sorry, the whole inverse of a is 1 of 15, 7, 4, negative 2, 1, 7, 4, negative 2, 1. And then we've got b, which is 11, negative 8. Now, again, I'm still going to leave this 115 at the front, but I can now say this is going to make this. This is going to make a 2 by 1 matrix. What is this 2 by 1 matrix going to have in it? 7 times 11 is 77. And 4 times negative 8 is going to be, let me see, 4 times negative 8, 4 8s are 32, so this is going to be negative 32. I do the same thing in red. I go negative 2 times 11, it's going to be negative 22. And then 1 times negative 8 is going to be negative 8. And then I just have to simplify these. 1 on 15, this ugly thing, this UGMO stands for ugly mofo. And no, Tristan, I'm not going to explain that either. 77 take away 13. So 32, sorry. So that's going to be 77, 7 take away 2 is going to be 5. And 7 take away 3 is going to be 4. So I get 45. Negative 22 minus 8 is going to be negative 30. And ladies and gents, this is why you wait till the end. And I didn't actually teach this when I was explaining this the first time. This is one of the reasons why I'm going over it, because I didn't explain this little trick. And I don't want you guys to think, oh man, I've got this fraction, I have to multiply it straight away. No, don't multiply it straight away. Because if you wait till the end, it makes life so much easier, because you can then go, hey, 45 divided by 15, that's going to be 3. And negative 30 divided by 15, that's going to be negative 2. And that gives us an answer. X equals 3, y equals negative 2. And just like usual, you can then take these and substitute them in. So what do you mean by substitute them in? You can then take them here and you can go, let's just double check over here. We'll go 3 take away 4 times negative 2 equals 11. 3 negative 2 times 11 makes plus 8. 11 equals 11. Sweet. We can even check it on the second one too if we really want. 2 times 3 plus 7 times negative 2 equals negative 8. 2 times 3 is 6 minus 14. 6 minus 14 does equal negative 8. That works. So that's how I would do it. So ladies and gents, that's why I would suggest leaving out the UGMO fraction. Just leave it out. So just carry it along all the way through, and don't deal with it till that very last step. That should help with a lot of these questions. Now, normally what we try to do in these questions, we try to make the determinant, like as teachers, we try to make the determinant either 1 or 10, because if it's 10, it's nice and easy to deal with. But if you do have to deal with an ugly fraction, just leave it out till the very end, and then it should be easier. Because if you compare it, right? If you multiply this, you've got to multiply 4 things by 1 on 15, and then you've got to do 1, 2, 3, 4 more multiplying by 1 on 15s, and then you'll get your answer. Whereas here, we only have to do 1, 2 multiplications by 1 on 15. ladies and gents, now, are there any questions on this? Any queries, any issues, anything that you don't know? So, if not, then that brings us to the end of the lesson. So what we're going to do here is I'm going to say, well, this is the kind. What am I going to ask you guys to do now? So what I'm going to ask you guys to do now is I'm going to say there are a couple of things you can do. The first thing that I think you should do, if you haven't done it, is finish off matrix exercises. After that, you guys can split your time between working on the revision sheet, for matrices, or the revision sheet for the exam. Did I? Exercises. Yeah, I think I did spell it wrong. Someone just said that I spelled exercises wrong. Yeah, I can fix that though, maybe. So I've never been good at exercises. Now, if you've done all that, which I find very unlikely that you will have done, all of the matrix exercises and the revision sheet for matrices and the revision sheet for the exam, what I can suggest is you try Edrollo. Okay, Edrollo is a great place for you guys to go. It has a lot of online tasks. Or you can ask me for some more work, because I may have some extension stuff. So those are the things that I want you guys to do. What we can do, let me just, and so yeah, those are the list of things that I want you guys to do. You guys have got now, between now and 3 o'clock, to work on those little bits and pieces that you might be having some issues with.